In this video, we will look at problems that fit TEKS objective 8.5a. We will solve linear equations in one variable, including those for which the application of the distributive property is necessary and for which variables are included on both sides. And I have a couple of suggested simpler practice problems here to look at. Suppose we want to solve 6 times x minus 7 equals 10 times quantity x plus 4 for x. Notice that we have the distributive property here and the distributive property here. So in order to solve this equation, we need to be able to apply the distributive property. And then notice that we also have variables on both sides. So this problem is a good example of the type of problems that meet this objective. So let's go ahead and solve it. First of all, let's expand. I like to rewrite the problem just to make it a little bigger. Also helps me to read it. Okay. All right. So first, let's take care of the distributive property. Let's apply the distributive property. 6 times the quantity x minus 7 is 6x minus 6 times 7, which is 42. Notice that the parentheses are gone now. Let's go to the right side. 10 times x is 10x, and 10 times 4 is 40. There are no more parentheses. So the next thing we need to do is solve this equation for x. In order to get the variables on one side, we need to decide what side we want them on. So I have a choice. I have a 10x on this side. I have a 6x on this side. So since my greater value is on the left, on the right, I'm going to let this be the variable side. So all my variables, I'm going to isolate the variable on this side. And so my other side, my left side, I'm going to call that the constant side. And that's where my numbers are going to go. I'm also going to divide my problem left to right. Okay? So we're going to use inverse operations to solve this problem. So let's use, if you look at the variable side, you notice that we have 10x. So we'll leave that alone. That's a variable. And we have 40, which is not a variable. It's a constant. So it does not belong on the variable side. So we are going to subtract the 40 from this side. But what you do on one side, you must do on the other. Okay. If you look on the constant side, you notice there's a 6x on the constant side. Since 6x contains a variable, then it does not belong on the constant side. And we're going to add its inverse. Okay? All right. And what you do on one side, you do on the other side. And notice that we have in fact added the same thing to both sides. So let's go ahead and simplify our equation. These are additive inverses. And we have additive inverses 0 pairs over here. So all we need to do is combine these two. Negative 42, 42 negatives, and 40 more negatives gives me 82 negatives. That's an 8, believe it or not. Okay. Equals 10x, take away 6x, or minus 6x, leaves 4x. So I end up with 82. Negative 82 equals to 4x. I can extend this page a little bit. All right. Maybe a little too much there. Okay. So in order to isolate the x, we notice that x, we still, on the variable side, we still have one constant left, and it's being multiplied times the variable. So we have to divide it out to get rid of it. And what we do on one side, we do on the other. Okay. You notice that 4 does not evenly divide a negative 82, but we can reduce it. this we can divide both the numerator and the denominator by 2, and you end up with 41, negative 41 over 2. We can leave that just like that. Of course, we know that those two divide out, and we're just left with x. And so our final answer is x equals to a negative 41 over 2. If you want to write that as a mixed number, you can also write that as 2 goes into 40 20 times, and with 1/2 left over, negative. But that's another way to write it, a negative 20 and a half. You won't see that much. Mixed numbers, negative. Okay, so there's example number 1. Let's look at another example where we do pretty much the same thing. Same thing. Get rid of this. All right, let's go to example 2. Let's look at this one. All right, make sure this is a different one. Yes, this one. All right, and let's do exactly the same thing. Let's rewrite the problem. Okay. All right. There are no distributors. Notice that we don't have the distributor property. So all we really need to do is get the like terms together, is to collect like terms and solve. So we can determine that, once again, our variable side, I'll just use a v this time, will be on the left because 16x, presumably more than 11x, or we'll use that. This will be our constant side. If we look at our variable side, we see that the 12 does not belong there, the minus 12. So we're going to use the additive inverse of minus 12 plus 12 to get rid of it. And what we do on one side, we must do on the other. If you look at the constant side, we have an 11x. Doesn't belong on the constant side. So we subtract that, and what we do on one side, we do on the other. Okay, all right. Let's simplify. Those are additive inverses. These are additive inverses. And 14 plus 12 is 26. Bring down our equal sign. 16x minus 11x is 5x. Okay. Looking at the variable side, I still have a 5 that doesn't belong on there because I want nothing but variables on my variable side. So since the 5 is being multiplied, we're going to use this multiplicative inverse. Divide by 5. What we do on one side, we do on the other. And basically, it's probably the best way to leave the answer. It's not really a simpler way to write that. So our final answer is x is equal to 26 over 5. Okay, and those are 2 examples on how you can solve linear equations using inverse operations. In one variable where we have the distributive property is necessary and variables are included on both sides. That concludes this video.